This is the first video for section 7.4. This section sort of sets up everything else we do for the rest of the chapter, so it's really important. So we're going to split it up between 2 days. First of all, let's talk about when you multiply two numbers and your result is 0. So those two numbers, either the first one was 0 or maybe the second one was 0. It doesn't even matter what the other one was, because we know when we multiply by 0, our result is 0. So either A is 0, the first number is 0, or B is 0, the second number is 0. So for example, 0 times 4 is 0. 3 times 0 is 0, and 0 times 0. Maybe they're both 0. We still get 0. Well, how is that going to help us? So what we're going to do is take our polynomials and we're going to solve equations with them. And often the first step of solving an equation with polynomials is to make the equation equal to 0. For this section, all of our polynomials will equal 0 already for us, and so all we have to do is solve each part of the polynomial. So for example, we have a binomial x plus 2 times a binomial x minus 3, and we're saying that equals 0. So just like the property up above, we know that either x plus 2 must equal 0, or the second number multiplied, x minus 3, that must equal 0. One or the other. Maybe both. So if we subtract 2 and solve this little equation, we get negative 2 as one of our x values. And if we add 3, we get positive 3 as one of our x values. As always, you can check your answer by plugging it into the original problem. So if we take parentheses, negative 2 plus 2, and we put negative 2 in again, minus 3. When we calculate that, the first parentheses is a 0, times negative 5. Well, 0 times negative 5 is 0. And then we can check the 3. 3 plus 2, 3 minus 3 equals 0. The first parentheses is 5. 3 minus 3 is 0. 5 times 0 is 0. So both of our solutions work. We've only seen two solutions one other time when we were working out our absolute value equations, but here's another opportunity where our equations are going to have two answers, sometimes even 3. We'll see that here soon. So let me take you through a few more examples. So we have two numbers being multiplied and we get 0. So what that means is either the 3x minus 2 equals 0, and then we'll solve. Let's add 2. 3x equals 2. When we divide by 3, we get x equals 2/3. So it is possible to get fractions. Notice that we got a fraction because we had to divide by this 3. So anytime we have a coefficient with the x, then we'll have a fraction. And let's be sure to solve our other part of the polynomial. X minus 1 equals 0. Let's add 1, and we get x equals 1. So there are the two answers, 2/3 and 1. You can check it if you need to. If you look at number 3, it's a little bit different. Our first part of the polynomial, actually we don't need parentheses because we're not adding or subtracting anything from x. It's just x, and therefore x would just equal 0. Imagine putting a 0 here. No matter what is in those parentheses, 0 times anything is 0. So 0 is one of the solutions. The other solution comes from x minus 8 equals 0. We can just add 8 and get x equals 8. So this one still has two answers. There's two x's in the problem. X equals 0 and x equals 8. I want you to look back at our answers and just notice this pattern. For example, we just did x minus 8 and our answer was positive 8. X minus 1 and our answer was positive 1. And let's look back up here. X plus 2, our answer is negative 2. So anytime there's not the coefficient in front of x, all we need to do is change the sign of the number we're adding or subtracting. So this negative 3 will become positive 3. So you can use that pattern if you want to. Just be careful, like on number 3 of your checkpoint, when there's that coefficient, then you'll get a fraction. So go ahead and try the checkpoints. I just wanted to make one note. If you look on the next page, all of this is going to lead us to two things. We'll be taking these polynomials and we'll be graphing them with parabolas, and we'll also be solving more equations like these. And have a good day. We'll see you tomorrow.